Firstly, we need all the purlin clip parts created in the model. Browse to Applications and Components and select Define Custom Component. We have 4 options to choose from. Custom connections are inserted with the main member and one or more secondary members and the parts inside the component. Select the Custom Connection option. Type in a name for the component and we will leave all the other options as they are. Click Next. Now we'll select all the parts that are created by the custom component. Hit Next, then select the primary member and select Next, and lastly click on the secondary member and finish. The custom component is now defined. We'll now go and add bindings and intelligence to this component. Select the component cone, right click and click on Edit Custom Component. Click on the Display Variables button. This is where we can type all our variables for the component. We start by binding the plate so that it is always created in the correct orientation. Click on the plate and now select all the node points on this plate by Alt Window selecting them from left to right. Right click and select Bind to Plane and click on the purlin surface that lies against the plate. Secondly, let's bind the plate bottom node points to the rafter top surface. And bind the plate top node points to the top surface of the purlin. Hide these distances in the variable list, since we don't need to modify them in the component. Now select all the node points and we'll bind them to the center line of the rafter. Now let's bind the bolts to the top surface of the plate. Select all the bolt node points, right click and bind to plane. Remember to set the surface back to boundary plane. We will bind the bolt node points to the center plane of the purlin. This way the bolts will follow the purlin if we increase the purlin size. And like everything else needs to be bound in 3 directions. We'll bind the bolts to the rafter center line. As you can see, if we move the purlin up or down, the plate follows. Let's now make the punching spacings work for different size purlins. On the custom component browser, select the secondary part and we will copy the profile reference information. Create a new parameter. Now type in the symbol equals and paste the profile reference. Next, let's create a parameter and type in equals round P1, 10 in brackets. This equation takes the value from P1 and rounds it to the nearest 10 millimeters. For future reference, we will just type in a name that will remember what this is for. In case you want to find out more information about the formulas in the component, in Google search for Tekla variable formulas and click on the link to the Tekla user assistance. We can find the round function under mathematical functions. Now let's set the bolt distances to follow the light side or Strament standard punching guidelines. Now let's set the bolt distances to follow the Lyside or Stramit standard punching guidelines. We'll set all the bolt distances from the purlin center lines to follow the same distance. On the bolt distance from the center of the purlin field, we'll type in equals if P2, which is our nominal purlin size, equals 150, then distance is 35. Or else, if purlin nominal size is 200, then 55. Or for purlin size 250, then 80. To finish off, we insert as many end ifs as there are ifs in the sentence. Also, let's set the bolt spacings according to the Stramit and Lyside punching. Create a new parameter and copy the sentence that we just created here. However, change the distance to double from what they were before. Now let's link this to drive the bolt spacings value in the custom component browser. First, copy the parameter name value. Click on the bolt and you will see this bolt highlight in the custom component browser. Select the bolt distance X and type in equals and paste the value. Do this for all three bolts. Now let's test if the bolt locations follow the purlin size correctly. Lastly, we want to make sure that the component works even if the purlin is oriented in the opposite direction. We will copy the plate on the other side of the purlin and insert a left/right switch for the plate. We'll need to add all the same bindings for the plate and the bolts on this side as we previously did for the other side. Now that you have created all the bindings, we'll add a left/right switch for the plates. Create a new parameter, value type yes/no. And give it a descriptive name. Now add a new parameter and we'll make this the opposite value from the previous one with the formula equals 1 minus P4. Now let's link the parameter P4 to the left plate and the parameter P5 to the right plate. Now let's go and test the component in the model. Save the component and exit the custom component creator.